In the summer of 2022, a laboratory at Columbia University ran a quiet experiment. There was no fanfare and no press release, just a camera, an AI program, and a pendulum. The researchers gave the AI a single instruction: watch the pendulum and identify the basic physical variables needed to describe its motion. The system had no preloaded physics equations. It just processed the raw video. The AI successfully built a perfect working model of the physical reality it was watching. But when the researchers tried to read the variables the system used, they found nothing recognizable. Velocity and angular momentum were absent. The AI constructed its answer using physical concepts that have no equivalent in human science. Professor Hod Lipson stared at the results on his screen. He realized that for centuries, we assumed the variables of classical mechanics were the only way to describe nature. This machine suggested that human physics is simply one dialect, and the AI had independently discovered another. The era of alien machine intelligence has started. It is operating right under our noses, solving physical problems using a language that human scientists do not recognize. In October 2024, the Royal Swedish Academy of Sciences awarded the Nobel Prize in Chemistry to an artificial intelligence system called AlphaFold 2. This was a first for the 124-year-old Nobel institution. They were recognizing the solution to the protein folding problem, a structural puzzle that had frustrated thousands of scientists since the 1970s. AlphaFold 2 predicted the three-dimensional structures of over 200 million proteins. It successfully mapped essentially every protein known to science, compressing a century of human effort into a few months. But during the press conference, DeepMind's Demis Hassabis admitted that they did not understand how their own system did it. He stated they were still trying to build the tools to analyze the inner workings of their discovery. Science is moving toward a new arrangement. We are shifting away from the requirement to understand why an answer is correct, moving instead toward a culture of trusting outputs we cannot trace. To see exactly how blind we are about to become, we have to look at the two distinct kinds of black boxes. The first box is classical AI, like the language models powering today's digital assistants. These systems calculate using billions of parameters. They are opaque because they are overwhelmingly complex. Given unlimited time, a human could manually follow every mathematical operation in a classical neural network. The path from input to output is practically hidden, but it is theoretically traceable. The second box is different. In December 2024, Google introduced its new quantum chip, Willow. This processor sits in a cryogenic chamber operating at 15 millikelvin, a temperature colder than the void of deep space. Running in that extreme cold, Willow completed a specific calculation in under 5 minutes. For the fastest classical supercomputer on Earth to replicate that exact calculation, it would take roughly 10 septillion years. Quantum systems inhabit a mathematical territory that is closed to classical computers. They calculate in a layer of reality that breaks our ability to track their reasoning. This visualization compares the total number of atoms in the observable universe to the mathematical space a 100-qubit quantum system inhabits. That quantum system exists in 2 to the power of 100 dimensions, a territory known as Hilbert space. The quantum computer allows all possibilities to exist in superposition simultaneously. Through a mechanism called quantum interference, incorrect answers interfere destructively and fade away, leaving only the correct answer to emerge. Humanity spent 4 billion years evolving to track predators and throw spears in a three-dimensional world. There was zero survival advantage to developing an intuition for quantum superposition or for operations happening in a femtosecond. We hit a biological ceiling here. Our brains physically lack the cognitive architecture required to navigate the dimensions where these machines operate. We are already testing that ceiling. By 2026, researchers began handing the design of delicate quantum circuits over to classical AI agents. This creates a structure of double opacity. A classical AI, whose exact reasoning we cannot fully trace, autonomously designs a quantum circuit, which operates in a physics space no classical computer can simulate. The cycle feeds on itself. Quantum computers run optimizations that accelerate classical AI training, and that smarter classical AI designs even more advanced quantum hardware. The loop spins faster with each cycle. Human agency is being pulled away from the center of discovery. Our role is shrinking to a single final task, checking the final results. This will move from the laboratory to your body. There are roughly 10 to the power of 60 possible drug-like molecules in existence. Quantum AI will search that chemical space to find targeted cures for pathogens and neurodegenerative diseases. It will also look outward. Quantum AI is uniquely equipped to process the staggering observational data required to decode dark energy, the force currently driving the expansion of the universe. The benefits will be impossible to ignore. Patients will survive, and the cosmos will finally make mathematical sense. We will have the exact right answers, but no human alive will actually know how those answers were derived. Imagine someone who has been completely deaf from birth experiencing a symphony by placing their hand directly on a speaker cabinet. They can feel the physical vibrations. They can experience the raw output of the music, but the musical logic and the harmonic intervals remain completely inaccessible to them. We are about to receive answers that solve our oldest medical and cosmological puzzles, at the cost of our own ability to understand the process.